introduce him to you.
This is a great school. Is this working? You guys hear me? Okay. Well, look, this is an opportunity for me to come here and talk to you about stuff that excited me. And when it excited me, I became so interested in programs such as this that I studied. And so you all know about STEM. I'm not going to talk to you specifically about STEM, but I'm going to talk to you about what it was like growing up and seeing airplanes fly and seeing spaceships and things like that, and how that encouraged me to do things. Now, this picture up here, you know, kind of shows the beginning of my program, my existence in NASA when I was very, very young. This is a picture of me after my second time that I commanded a mission. And in fact, that's the same suit that I have on right now. I was a lot smaller then, so it's a little tight now. But I wanted you all to see that. And this is me as a bureaucrat, a person who makes policy when I was at NASA headquarters. So, you always have to be bona fide. This is me right here. And this is one of my crews, and we're getting ready to get on that vehicle. And that's the Orbiter Discovery. And it gives you a sense of your age when you fly it when it's brand new. This is now in a museum someplace. It happens to be at the Air and Space Museum near Dulles Airport in Washington, D.C. Well, I flew the Challenger, the Discovery, and the Atlantis. And we are about ready to move into Discovery, and we're going to walk across the bridge. We're standing right here. We're going to walk across the bridge and go into this room right here, that box NASA called the White Room. And inside the White Room, we meet suit technicians. And those are the folks there responsible for making certain that our suit is on, that we have all the pieces and parts. They give us some additional equipment like this little beanie cap that Leland has on right there. And when they are ready, they may stick a ham and cheese sandwich in our pockets. Then we get on our hands and knees and crawl through that hole right there. That's the orbiter right there. Now when we get inside, it's going to be a little confusing to you. So we're going to take this room that we're sitting in right now, and we're going to rotate it like this. So now all of your seats are on the wall. So when you crawl in, you'll see your seats, but they won't be like this. The back will be here, the bottom will be here. So you crawl, you find your seat, there's a chinning bar next to it, you reach up, grab the chinning bar, pull yourself up, scrunch your butt on the back of the seat, and then slide down as far as you can in the seat. Then the suit tech comes in, and she will push you physically further down into the seat so that you are as tight as you can. And then she will begin to put your straps on you. There are about 1 million of them. She says it's for my safety. I know it is so I cannot escape. And so once all the crew is in there, the suit techs gather all of their equipment, they come through that hatch, they close the hatch, they latch the hatch, they put tile on the hatch, they put super glue on the hatch, they put duct tape on the hatch for our safety. They then cross the bridge, get on an elevator and come down to the ground floor, get in their vehicles and depart at the speed of light. And we're wondering, why the heck are they doing that? Until we realize what we are sitting on up there. Now this is the way we look. This is Shep, helmet on, gloves on, lying on his back, looking straight up like this. This would be north right here. So let's see if I can get rid of this thing. Oops, too far. Okay, here we are in the Orbiter Discovery. I'm on the right side, My pilot is on the far left. There's the rest of the crew. Sonny is behind the pilot. Story Musgrave's in the middle. And notice, that's Kathy Thornton back there. That's KT. Her name, she is Dr. Catherine Thornton. She's a professor of engineering at the University of Virginia. She's an amazing person, so if you're ever down that way, stop by and see her. But notice all the switches and gauges and things like that. There are probably 2,000 of them in there. And we have to know what each and every one of them does before we lift off. Now this is the orbiter, and you all know about that. The thing with the wings on it, the shuttle, it has 3 engines, rocket engines on the back. And those rocket engines get their fuel and oxidizer from stuff that's in that big brown tank. And that stuff is just liquid hydrogen and liquid oxygen. So hydrogen is the fuel and oxygen is the oxidizer. On either side of the tank are these 2 very large rockets, huge rockets. So what happens in liftoff? We'll count down 10, 9, 8, 7, 6. At 6 seconds, the main engines on the back of that orbiter ignite. 5, 4, 3, 2, 1. At 0, the solid rocket boosters ignite, and there is no doubt you're going someplace really, really fast. And this is kind of the way it looks. See the orbiter there? The 3 engines are on the back. You'll see it. These are the 3 engines. At 6 seconds, they ignite. You'll see the flames. 6, 5, 4, 3, 2, 1. Bam! This is the way it looks inside. Just shake, rattle, and roll inside like that. So 10 seconds, we go straight up. Then we roll over on our backs. You all are now the Atlantic Ocean. 18 minutes after we take off, we cross Portugal. 18 minutes. 2 minutes after we take off, the solid rocket boosters have burned all their fuel, and they will blow away from the tank. And you'll see that. You'll see that in right here. It's too much stuff for me up here. And here's the solid separating the blast inside. So those are the solids. Parachutes, the nose of those solids deploy, and those solids would drift back down and land in the Atlantic Ocean. NASA had crews that would go out and fetch them about 150 miles off the coast, pull them back to shore. They'd be shipped to the manufacturer up in Utah for refilling, refurbished refilling, and they'd be sent back to Kennedy for reuse. The main engines continue to accelerate the orbiter to orbital velocity. And you guys know what that is. That's the speed that the orbiter has to achieve to enter a circular orbit around the Earth and stay there. And that speed is 17,500 miles an hour. 17,500 miles an hour. Going 17,500 miles an hour, you circle the Earth every hour and a half. You go completely around the world. Every 90 minutes. And of that 90 minutes, 45 minutes of it is bright sunlight like today. And then the sun is gone. It is pitch black for 45 minutes. And then it's bright sun. And so in a typical Earth day, we see 16 sunrises and sunsets up there. And this is kind of the way, oops. See, we did that once. Okay, this is kind of the way it looks when we get up there. We're about 300 miles above the surface of the Earth. This is Earth right here. This is space out here. But space doesn't look like that, actually. When you have a very bright object like this, Earth, and you take a picture of it, if you don't have a flash, you're not going to see what's out there. So that's why I said it's kind of the way it looks when we get out there. This is the space shuttle right here. if you can think of the space shuttle as an 18-wheeler, the front part, the cab, would be the equivalent of our crew compartment, where the crew hangs out. Behind the cab is the trailer. This is the payload bay, so that's the equivalent. The only purpose of the shuttle was to carry stuff to space and bring stuff from space back home. You could put 1.5 school buses back in there. It's really, really big. Now, when I was a kid, I spent a lot of time at airports. And I was able to wander around and see airplanes such as this. These are old airplanes. But you could go touch them, and you could talk to the pilots. And I got at a very young age excited about airplanes. And then I saw these guys, the Thunderbirds, which is the Air Force demonstration team. The Navy has something called the Blue Angels. But those are just recruitment tools that the Air Force and the Navy use to encourage youngsters like you all to become part of the military force. But when I talked to pilots, they would say, you know, you're going to have to study to become a pilot. And I asked them, well, how could I become a Thunderbird pilot? And one of them told me that I should go to something called the Air Force Academy, this thing right here. And I went, South Colorado, near Colorado Springs. And it was an interesting school because everything I learned there, you know, I didn't realize how important it was at the time. But 60% of that which I learned was science and engineering and math and technology. 40% of it were all those other things like political science and English and history and just all of those other things. And so what I found out was having this engineering degree was great, but I also needed that other part too. And that's what this school taught me. From there, I became one of these pilots. And in fact, this is me right up here. And I'm going about 1,200 miles an hour right there. Well, now with my education and the experience I had flying, I applied for test pilot school. And I needed the academics, but I also needed the flying experience. And so I became a test pilot. And then as I became a test pilot, I got kind of tired being a test pilot. And so I saw an advertisement once about applying for the astronaut program. And I thought, my goodness, that sounds like something to do. And so I applied for the astronaut program, but again, I had no interest or desire to be an astronaut. I just thought, you know, it's just the next kind of thing. And when they began to look at my background, I had flown helicopters, I'd flown fighters, I was a test pilot, I had this academic background. And so I applied, and somehow I became one. And that's a tough picture, but that's me right here. Now in this group were people like Sally Ride, right here. And you probably know her name. You have the first African American to fly in space, Guy Bluford here. You have a lot of folks in here who, if you ask them how they became astronauts, they would say, I have no idea. Because I can think of 10 or 12 people much smarter than I am. They're big, no ego in this group. All of them type A. All of them willing to take a chance. But the interesting thing about this group is that every one of them not only was a great engineer or scientist or medical doctor or whatever, but they also did other things, like they were a terrific softball player. Well, they played the bagpipes, or in Sally Ride's case, she was a professional tennis player. And so all of them were not just this, they were this. And I think that's what they were looking for when they made this selection. Now, I trained to walk in space, and that's me in that. And we walk in space, we practice in a big swimming pool. And the only difference between space and this water swimming pool is that in a swimming pool you can actually swim and move. If you did that in space, you look stupid because you can't move at all. Now, I did not actually have to walk in space on this particular mission, but it's a training that you go and you just never ever know what you're going to do before you go. Now, one of the first things that impressed me when I got to space was looking out into the heavens. And it's a beautiful picture when you look at it, until you realize that at the speed of light, it took 10 million years from the light from that sun to get to your eye. So if it were a flash, it would take 10 million years for the light to get to you. For this one right here, it takes 12 million years to get to you. Here, it's 8 million years. So this is not flat. It's something with infinite depth out there. And we've discovered now that many of these suns, which is what they are, have planets just like our solar system. And we've also found that some of those planets look just like our Earth. So I would anticipate that one day, one of you all will be able to go out there and meet a friend on one of those planets out there. And it's not going to be an enemy or an alien. It's going to be a friend. And it's going to be fantastic to see whether you can shake hands or whatever you do out there. But it's an amazing thing. I think God put that out there so that it would entice me to take the journey and take that trip out there. But I'm too old for it. I'm going to leave it to you all. When you look down at the earth, I call this dirt. You see things that are looking happening right now. And so if there were a storm moving across that dirt, you would actually see the movement of a storm. And you see the flashes of lightning inside. But when you look down, you can tell immediately where the predominant wind comes from, where the mountains are, where the best place to go fishing is. The wind comes from this direction. Picks up moisture from the ocean, and when it rises over that dirt, it turns green and lush until it gets to the mountains. And on the windward side, it's very green. On the leeward side, it's very arid. You'll see some puffy clouds in here that are just sea breeze clouds, but you can see the difference in color of water between here and here. The lighter water generally indicates colder water, water that's upwelled from the bottom of the sea. And when it rises, it brings nutrients and plankton, and fish love it. So if you were going to go fishing, that might be the place to go right here. Now, here's something, this line that you see right here. We all know about cold fronts. Cold air, warm air rising. And on Earth, when that happens, you'll get storms and thunderstorms, and you can get tornadoes and things. Here is a cold front in the water, right here. Cold water here, warm water rising up over it. And if you were in a boat and crossed that, it would be very, very rough. Then you realize water and air are both, they're both the same. One is denser than the other, but as fluids, they both have similar characteristics. And you can see how they react amongst itself, and then when it hits this dirt right here. And I wish that in the 4th grade I had been able to go to space, because looking at it from space, it makes sense to you. And it's so different than being in a classroom. But that's one of the journeys that you then need to go on to. Well, the aurora, they're particles out in deep space attracted to a magnet, Earth. And when those particles react with our atmosphere, this is what you get right here. In the north, we call it the northern lights of the borealis. There's almost a mirror image of it on the southern end of this world. We call the Australis, or the southern lights. And I wanted to show you this thing because it's not static like this. It actually moves. So this is a picture from the space station looking down at the aurora. And you can see it moving. But interesting, here is the edge of the Earth right here. And then this is our atmosphere. And that's what we live in there. So, what's up and down in space? There is no up and down in space. And that's one of the great things about going to a place you've never been before. Because every time you go there, you will see and experience something entirely different. So when you do science experiments on Earth, when you go to space, it may not be the same. For example, we can mix water and oil in space, and they come together. You can't do that on Earth. And that's all a function of gravity down here. But it's amazing because we carried monkeys with us. And you can see the little cage right here. This is a rhesus monkey. And we took them up there, not to do anything with them, but to check out the little cages that they were in. And so on future missions, then we could carry animals with us, and we could then use them and give them a very humane time to spend up there. This is a Coca-Cola bubble right here. We've blown bubbles on Earth with soap bubbles. This is Coca-Cola here. But you would never imagine that if you poured out a liquid, that's the way it was. You could put a straw on that and suck it right down. Here is a part of the space station. And this is a laboratory right here. This is a lot of storage back here. But the work that you're doing here at Talbot will be the similar kind of work that you would do when you are on space station in the future. Here's another view right here of work that's being done up there. So it's a fantastic experience. It's time to come home. So we deorbit. We do deorbit about 10,000 miles from home. And when we deorbit, we slow up, and then we fall back to Earth. It takes a little more than an hour, and it's 10,000 miles. And we're a glider. We don't have any power at all after that. And so we will come through some very hot air. The temperatures on the outside of the orbiter approach 2,500, 2,600 degrees Fahrenheit, but we're just as comfortable inside. And here we are about 80,000 feet above landing at the Kennedy Space Center.
Excuse me, Colonel Gregory? Colonel Gregory?
Yeah.
Could the kids ask some questions now?
In just a second.
Okay. Okay.
Okay, here we are making an approach to the runway at the Kennedy Space Center. It's a big glider, remember, and we're going to pull up about 2,000 feet above the ground and then drift and touch down very, very gently here at the Kennedy Space Center, which is kind of right there, down there. So with that, now you can put somebody up there to ask a question.
Thank you very much. Number one. Come on. Josh, you're on deck.
Okay, folks. First question.
What made you an astronaut?
You know, in my career, I did lots of things, and when I got tired or bored doing it, then I changed careers and did the next thing. I was a test pilot, got bored, and I saw the advertisement to be an astronaut, so I applied. It's not something that I had a long-term wish to do. In fact, I got tired of being an astronaut and left it. So you can have long-term plans, but most of the things that you do in life will be something that you decide to do maybe on Friday, and then wake up on Monday and do it. Yes, sir.
What specific type of training would you have to go through before space?
Well, you're part of it right now. It's all the education that you receive in primary, middle, and high schools. And then adventures that you go out on, you know, all by yourself without any parental supervision. And you go out and you discover things, and that gives you that sense of exploration. So when you put all of that stuff together, then that's kind of the preparation that's necessary to get into a program such as this.
Thank you. What does it feel like to take off from the space shuttle?
What? Say it again?
What does it feel like to take off from the space shuttle?
Oh, you're going to love it when you do it. There's a lot of noise, a lot of sound, and you do a lot of shaking. And when I told you earlier about when those solid rocket boosters are on the tank and they blow away, as soon as they blow away, it's a very smooth ride. What I forgot to tell you was, it only takes 8 minutes to get to space. So you go from 0 to 17,500 miles an hour in 8 minutes. You're just going to love it. Next one.
Stop. How did you handle all the pressure taking off to space?
No, there's no pressure.
Huh?
There's no pressure. You mean the G-forces?
Yeah.
No, you know, it was very civilized. You had about 2.5 Gs, and that's really nothing. So it doesn't rip your skin off. It takes your hair off, but it doesn't rip your skin off.
How did it feel to be in space for the first time?
What was it? I'm sorry?
How did it feel to be in space for the first time?
Oh man, the first time you go up, it's in total disbelief. And it's like the first time you've done something. And you look back, look around and see if anybody's noticed that you're there, and then suddenly you go, yes! And that's the way it is when you have to. But then everything's floating around, even your food. If you want to have some fried chicken, just let it sit there like that. It floats. Just grab it and eat it, then let it go back up there.
What is being in a spacesuit like?
What is in the orange one or the white one? Well, the orange one that we launch in weighs about 75 pounds. And you've got pretty good motion in it. The white one weighs probably 375 to 400 pounds. But you're weightless, so you don't feel it. It's heavy. And it has joints